All right, let's take a look at light waves and electrons. So remember that we're trying to express the arrangement of electrons in atoms using electron configurations. And that's what we're going to do right now. So the electron configuration is just a label for where all the electrons are in an atom. And the location of electron is defined by two things: the energy level that it's in, which is the area around the nucleus where the electron can be found. And this is going to be represented by a number, where the first energy level is labeled 1, and every energy level after that is just another number. So 2, 3, 4, so on. And then the second thing is the sublevel where the electron is in. And this is that more defined region within an energy level. And these are going to be labeled S, P, D, or F. And we're not worried about where these letters come from, but what I want you to know is that electrons will fill S first, then P, then D, then F. So they fill in that order when the sublevels are there. S's fill up first, then P's, then D's, then F. Now, let's take a look at that sodium example again. And we're going to walk through this example and see how I can label these peaks to get the electron configuration. So we're going to first break it down into our three energy levels. The first energy level is the one furthest to the left. That's why it's plotted with this backwards axis. Then we just count. Second energy level, third energy level. And remember, these big gaps show me where my energy levels are. Here I'm using dotted lines to show you very clearly that there's a big gap. Now, that first energy level has one peak. It is in the first energy level, so we're going to call this one 1s. 1 because it's in that first energy level, S because the first peak is always labeled S. Those are the first sublevels. Now, in the second energy level, I have two peaks. We start with the first peak, and it's going to be labeled 2 because it's in the second energy level, and S because it's the first sublevel in that energy level. And the next peak is still in the second energy level, so we're going to call this one 2p. S, then P. If there was a third sublevel in this energy level, then we would call it D, but that doesn't exist for the second energy level. And now this last peak is in the third energy level, so it's going to start with 3, and it's the first peak in the third energy level, so we're going to label it 3s. And now I'm going to add a little more to this, because it actually turns out that not only do I want to write out the energy levels and the sublevels, but I also want to tell somebody how many electrons are in each sublevel. And so we're going to use a superscript, a number that is slightly above the line. See, it's above and smaller, to tell a person who is looking at electron configuration how many electrons are in that sublevel. So here in this 1s, it is 1, 2 electrons, and I'm just counting the height of this peak. On this chart, every line is 1 electron. So this is now going to be labeled 1s2. This is the first part of sodium's electron configuration, 1s2. The next peak is also too tall, 2s2. The third peak is 1, 2, 3, 4, 5, 6 electrons. So this is going to be 2p6. And then finally, the last peak is only 1 electron, 3s1. This is the electron configuration for sodium.